Now, most of you have some pretty good experience and background with doing volume. And when we're thinking about volume, we're thinking about actually filling up a 3D space. It's not trying to wrap it like with a package. This one, we're really filling it with how much will go into it. And we measure those in cubes, cubic centimeters, cubic feet, cubic yards. This diagram gives you a real good example showing that we've got 3 cubes on the bottom, 4 cubes on the side. So there's your first layer. So the area of that base would be 12. And we're actually going to have a new letter that we're going to think about. It's called big B. Big B, capital B, means the base of a 3D figure. So on this rectangular prism, the bottom of it, we've got a rectangle. And now we're stacking up to add height. So there's that length times width, and then times the height of the actual shape. You'll see this formula written a little bit differently. Let's take a look here. Again, I've got another rectangular prism, and I'm thinking, yes, I can do length times width times height. I can also think of this as big B, the area of the base times the height. And this is probably the easiest way to do this because this formula, big B times height, takes care of the volume of any 3D shape that is a prism. So taking a look here, again, B is just the base. Big B is the area of the base. So if I was to do the formula for this, I would again do 4 times 3 is 12. That would give me big B, and then multiply that times the height to get the total number of square units. I can use that same formula with different types of prisms. If I've got this trapezoidal prism, I've got to think about what is the base. The base, is the trapezoid. That's why they call it a trapezoidal prism. I kind of like to rotate these and put them on end because that helps me to think about it. Where's the base? It's the trapezoid, and then I kind of pulled up. Have you guys ever seen those cups that are like the collapsible cups that you grab the top and then stretch them out? You see them sometimes in dog parks. They'll have like a collapsing cup that you can take to a dog park and then fill it up with water. It collapses into something that's flat and two-dimensional, but then you can pop it up into a cup or a cylinder. And when I look at prisms, I think of the same thing. What's the base that I would stand it on the end? And then I've got to pull up to create a height. So again, the neat thing is, all I have to remember for the volume is I need the big B, the area of the base, times the height, which is why we needed to figure out why to do area of a trapezoid. So in this example, I have to think about base 1, which is 6 centimeters, plus base 2, which is 12 centimeters. I need to cut that in half and then multiply it by the height. And I need to look here for the height. I'm not going to look on these outside edges because, again, if I were to run up to the top of the shape and drop a line off, it's going to come down. So the area of the base then is 144. I'm not done though. I've figured out what this area is. Now I need to multiply it times the actual height of the shape. So my 144, which was big B, right here, big B, 144, times 10, which is the height of this shape. And again, I can think about it, rotate it mentally in my head. There's the base. This is how tall it is. That's the height. So that gave me 1,400 centimeters cubed. And yep, I'm filling it up with cubes, so it's cubic centimeters. Let's take a look at this next shape. Again, this is a triangular prism. So yep, triangles are the base. I can rotate it around and I can think, okay, I have a triangle. I pulled up 8 meters to create this prism. So the first thing I have to do is to find the area of the base, big B. So for a triangle, I know I've got 1/2 base times height. So 4 times 5, half of that is going to give me 10. So big B is 10. The height of the figure is 8, or 80 centimeters. And now if that's not enough, yes, we have composite solids. And it's not that much harder. So I want, before we start, do we actually need to do some subtracting just like when we did composite surface area? Not so much, because I'm not measuring outside, I'm measuring what's inside. So no subtracting here. I just need to find the volume of this shape, the volume of this shape, and the volume of this shape. And when I look at it, these two are actually the same. This triangular prism, they're 3 by 3 by 4s. So if I do those two first, the base, big B, is going to be 3, and I can see that side right there, 3 times 4. So that gives me what the base is. So the base is going to be 12, and then the height of that shape is 3. So big B is 12. Big B is 12, then times that height 3 to give me 36 feet squared. But I've got 2 of them, so 72 feet squared for this shape and this shape. Now I just need this figure here. And I really have to kind of look around. They're showing me the 1 here, the 1 here, the 2 here. Okay, so this is a 2 by 1 by 1. So finding big B first, the base of that is going to be that 2 times the 1, which is just going to give me 2. And then I've got big B times the height. The height is also 1. So that one's just 2 feet cubed. So if I take my 2 large prisms, 72 feet cubed, my 1 small prism, 2 feet cubed, and I put that together, I'm going to wind up with that 38 feet cubed. Now it's your turn to try some of these shapes.